Let's take a minute to look at some of the topics that are covered in this chapter. We're going to look at primarily variables and how they are used in programming. We'll look at the different variable types, and we'll even accept input from the keyboard. So looking at variables, we have different types of variables. A constant variable, which cannot be changed as the program is being compiled. Literal constants, variables. Variables can change the value which is stored in that memory location, and not only can it change, but it needs to be a certain data type. And in other words, whenever that information is stored in that memory location, it has to be a certain type of variable. So you have a list of the different types of variables that we'll be looking at. Double, used probably primarily most of the time that you'll be declaring variables that have a decimal value. String, Boolean, yes or no. Character values, which use just a single character from the Unicode character set. And objects. The integer data type is whole numbers, so no decimal values for those. So let's go ahead and take a look at some of the examples of variables and how we can write those. So a double value, what it does is it blocks out a location in the computer's memory, and in this case we give it the name some money, and only values which are double, in other words values which have a decimal value, can be assigned to that memory location. So this equal sign is not really an equal sign, it's an assignment character. So it's saying assign the number 39.45 to this variable called some money, and it can only save the data type double. And then in this line it says write the line, whatever's between these parentheses, to the console. So let's go ahead and start up our IDE and let's create an example. File, new, project. Let's make it a C# project. Windows. Well, let's make it a console application. And here, let's change the name. Give it something a little more descriptive. Okay. And make sure that I know where this project is being saved at. Right now, it's in the projects folder. Okay. Click OK for that. The using allows us to include these groups of code, of objects which have already been programmed, without having to actually list exactly where they are. Beep. Using allows us to include blocks of code. Beep. Using allows us to include a namespace, and a namespace is a lot of code which has already been written, which we don't have to write ourselves. We can just say using, and then whatever that namespace is, we can use all the programming code that's already in that namespace. Now actually we don't have to have using in this case text. What we could do is that anything that's in that namespace, the system.text namespace, we could use that, we could have access to that, but we would have to, every time we use something from that, we'd have to have a long path to say exactly where that's at. So using is a way to simplify that. So let's go ahead and write our first program, and let's use the example from the textbook. So what we have here is a variable, and we named it sum money. Notice this variable starts with a lowercase. So we named it sum money, and we assigned the value 39.45 to that. Now we want to display what's stored in sum money to the console, so we put in this console write line sum money. But instead of just having that number pop up out of nowhere, what we do is that we put a little bit of text description on this, and we say the money is, and then $sign. So here's some questions. Why write, and why write line? Why is this one in double quotes, and why is this one not? Well, let's go ahead and run this. But before I do, how about if we do this? Okay, so you know what that does, right? Debug, start debugging, and when our program runs, it does, oops, exactly what we told it to do, which was create a variable, initialize it with a value, display to the console the money is $sign. The money is $sign. And then on the next line, you notice write will stop right here. The cursor stops right here. And then on the next line it says, okay, write out to the console whatever's stored in sum money. And what's stored in sum money? This value right here. Okay. And then it pauses the output, right? Okay. Let's quickly look at some of the other things that we can add to our program as examples. Formatting a string, placeholder, let's see how those work. So, oops. Okay. So here we have sum money. We've stored a value into that memory location called sum money. Now we want to output that. Here's one of the ways that we can do it. We can say in between those double quotes, we can say the money is and $sign. We had that before, but here we have the curly braces and a 0 in there. So what does that mean? And then at the end of these double quotes we have a comma and then sum money. So how does that work? Well, what happens is that it always prints literally or exactly what's between these double quotes, except in this case where it sees the curly braces and 0, it goes to, the 0 says go to the very first variable and take the value that's stored in there and replace this with the value that's stored in that first variable. So computers start counting at 0, so this is the first location, the first variable. So if there were, say, 3 variables, it would be 0, 1, 2. So in this case we just have 1, so it's 0. Okay. How about formatting output? Well, what you can do with that is there's a lot of choices on that. This is kind of basic and primitive, but what this is saying is take the first value, and in this case after the comma there's only one, so take the number 4, put 5 spaces, and align this to the right, so the 4 will come into the right. Same thing with this one, 5 spaces for the 56, 5 spaces for the 789, and you will right align that. And on this one it's saying take the first one, which is Richard, align that to the left. That minus means align that to the left with 8 spaces, and the number 1 means take the second one, a second literal, and align that to the left and use 8 spaces. Okay, concatenation, that's where you join two strings together. So in this case it would take the first string, and this plus symbol is the concatenation symbol, and it says join those two together. So when this outputs to the console, it would say concatenated space string. Okay, whole numbers. Different types of data types that contain whole numbers. Variables with floating point numbers, float, double, decimal. You notice that these have more and more accuracy. 7 significant digits, 16 significant digits, 29 significant digits. Operator precedence. So when you have a mathematical calculation, how do you know which numbers to add first, or which ones will divide, or which ones will be evaluated first, second, third? So in this case, the addition symbol plus, subtraction minus, asterisk, forward slash, and this percent sign, modulus. So what's modulus? Modulus is just the remainder of a division. So with modulus, remember whole numbers. So in their example here, 45 modulus 2. So if you divided 45 by 2, you would get the number 22, but there would be a remainder of 1. So the modulus is 1. Remember, the modulus is the remainder. So what's the answer to this? 5 modulus 2. What's the modulus? Well, if you took 5 divided by 2, you would get 2 with the remainder of 1. So the modulus is 1. What about this one? 6 modulus 2. 6 divided by 2 divides evenly and gives you a whole number of 3, and there is no remainder. So the remainder is 0. So the modulus is 0. 7 modulus 2, 8 modulus 2, 9 modulus 2. Okay. Here we have prefix increment operator, postfix increment operator. What it will do is that it will add, in this case, it will increment by 1 every time through. So this value, whatever some value is, will be incremented by 1. Again, this value will be incremented by 1. The difference is this one will be incremented by 1 as soon as this value is processed. This one will be incremented by 1 after this value has been processed. And with the decrement operator, it's the opposite. Instead of incrementing, it can decrement or go down by 1. What if you want to increment or decrement by more than 1? Let me go back up. And here you can have, look at this at this statement. Bank balance equals bank balance plus equal times interest rate. So what this does is that it takes the current bank balance, adds that on to, or in this case multiplies by the interest rate, and stores it into bank balance. The next time through, bank balance will be increased by the interest rate, and it will just keep incrementing by that amount each time it goes through. So when we take a look at loops, this will become very important. Boolean value, true or false, yes or no. These symbols, the operator, this lazy L means less than, this greater than symbol, and this means equal to. Not the sign, not just one equals, but two equal signs means equal to. So 7 is equal to 7. This is true. 3 is equal to 9. This is not true. Okay. Less than or equal to, and you'll notice it says or. Greater than or equal to. So 5 is less than or equal to 5. That's true. 8 is less than or it's equal to 6. And neither one is true. 8 is not less than 6. 8 is not equal to 6. What if you have a data type that you want to change? You have an integer value, and you don't want it to be an integer anymore. You want it to be a decimal value. Well, what you can do is that you can cast it. Now you can do it implicitly or explicitly. In this case, you have an integer and you're storing it into a variable, which is a double data type. So you're casting this integer into a double. In this case, you explicitly do it. You're saying in parentheses, I want this value to temporarily become an integer. So change this double value to an integer. So if a double was 5.333, if it becomes an integer and stored into an int, it would just become 5. Character data types, just a single character, and you'll notice that it's declared here with single quotes, not double quotes, but single quotes, a character data type. What if you took a character and put another character next to it and another character next to it? Pretty soon you have a string of characters. Well, that's the string data type. And you'll notice that the string data type, in this case, you can see the example has the string of characters in between double quotes. Now, once you have a string, there's a lot of different things you can do with them. You can, in this case, you can compare them. You can compare string, the variable name1, which is a string, to name2, to name3, and you can see if they're equal to each other. What if you have a variable? You know there's a string stored in this variable, but you don't know how long that string is. Well, there's a way you can do that. You can say print out, this variable is called a string. You can print out the length of a string. Sometimes you don't want a variable to change values as you're going through the program. You might have something like interest rate. The interest rate may be fixed as this program is running. So you want to create a constant, something you don't want to vary during the program. And enumeration. And enumeration is simply, it's a variable that contains a set of constants. So in this case, day a week is in essence your variable name or identifier, and it represents all of these different strings, these 7 strings, which happen to be the days of the week. Now, something that we've used already is readline. Now, the readline method, what it does is it pauses the output and it's waiting for the user to enter in information, normally from the keyboard. So when you type in something from the keyboard, it takes that and reads that and stores that string. So let's look at this example. We have a tax rate which is going to be fixed as the program runs, so we make that a constant. And it has a decimal value, so we make it a double data type. The next one is a string data type, item price as string. A double, item price, a double, which is total. So the first thing when the program runs is it says write to the console whatever's between these parentheses, and in this case it says enter the price of an item, and you notice it says write, so output will pause right here. The cursor will be sitting right here. The next line, it says read it, the output will stop and it will pause as you read line, and when you type in that value, whatever value you're typing into, whatever value you type into your console, it will store that into item prices string. Now, this is going to be a number, so you don't want so why did we make item price a string? Why did we first make that a string? Because when you read it in from the console, when it reads in, it will be a string. Anything that's read in from the console using readline will be a string, so you have to save it into a string data type. So you want to add, subtract, multiply, or otherwise calculate with this number. You can't do that with a string, so what we need to do is we need to convert this to a double. So we take item prices string and we say convert convert this into a double data type and place it into item price. So now we can go ahead and do the calculations. Okay, we took a look at some of the things in the chapter. We did do a very small example. We didn't get a chance to practice all of the variable and data types in our little example exercise. But take the time to read through the chapter, try out the different exercises, and then continue on. Okay, that'll do it.